Fire is more than just heat and light. It is a fascinating display of chemistry. Have you even noticed how flame can be red, blue, green, or even purple? These colors aren't random. They reveal secrets about the materials being burnt and the temperature of the flame. So, what is a flame? A flame is the visible part of a fire. It is created when a fuel reacts with oxygen in the air, producing heat, light, and energy. This process is called combustion. In this video, we will explore the science behind the flame color and how different substances, especially salt, can change what we see. Here are two main factors determine the color of a flame: the chemical composition of the material being burned and the temperature of the flame. Different chemicals, especially metal salt, can create a wide range of color. Higher temperature produce blue or white flame, while cooler flame appear red or orange.
How does different salt affect the color of flame? So, you may be wondering, how do salts affect the color of flame? Well, when an electron goes from a region of lower energy state to a higher one, it must absorb energy from the surroundings. This is known as excitation of the electron. When going from a region of higher energy state to a lower energy state, the electron releases energy into its immediate surroundings. This is called the de-excitation of the electron. The difference of energy between two energy levels differs from one metal to another. Same goes to their wavelength as well, which means each different metal will have a different pattern of spectral lines, and so a different flame color. Therefore, flame colors are produced from a transition of electrons from a higher energy levels to lower energy levels in the metal compound. Now, for your better understanding, I will now do a demonstration. The color of the emitted light is unique to each element and depends on the specific amount of energy released, which varies because each element has a different number and arrangement of electrons. For example, as you can see, when sodium is added to a burning Bunsen burner, it will emit a bright yellow flame. Once the sodium starts burning, the electron will start to move to a higher energy state, from S to P, then falling back again to its original state. This process will keep repeating in the sodium as long as it is burning. Next, for burning of copper, it will emit a greenish blue colored flame. Potassium will be like a lilac or purple colored flame. And lastly, lithium will emit a pinkish colored flame. Moreover, different compound will emit the same flame color provided that it contains the same metal ions. Like for example, sodium nitrate and sodium chloride. When these two compounds are burned by Bunsen burner, they both will emit the same wavelength, which provides the same color, yellow colored flame. And just a quick reminder, please do not try this at home. Moving onwards, we will now talk about how different temperature changes the color of flame. This actually depends on the result of combustion. As we know, incomplete combustion occurs due to insufficient of oxygen, so the flame will be a reddish or orange colored flame. On the other hand, combustion with sufficient oxygen will show a bright yellow, white, or blue colored flame. As the temperature of the flame increases, its color changes from red to orange, then to yellow, white, and lastly blue. But you may be wondering, how? During combustion, electron loses energy, therefore the excitation of electrons occurs. As the de-excitation electron releases its energy through the emission of light, energy is transferred to photons. Photons are the particles of the light. After energy is transferred to photon, light will be emitted from the atom. Depending on the energy change of the electron, the energy provided to the photon will also vary. This results in different wavelengths of light being emitted by different energy changes. Since varied wavelengths correspond to their own individual colors, it results in the emission of different colored lights. Again, for your better understanding, I will give a few examples. For instance, at 500 to 800 degrees Celsius, the flame will change its color from dark red to bright red. Normally, you will see this during the burning of wood or paper. Then, from 850 to 1050 degrees Celsius, it will be orange color, which you normally see when using a gas stove. Then, the flame will slowly turn into a yellow color at 1100 degrees Celsius, white color at 1400 degrees Celsius, and finally, blue color when it exceeds the 1500 degrees Celsius mark. Blue is also the hottest flame color out of the rest that I just mentioned, just for your information. Now, by knowing the basics of how different metal salts and temperature changes the color of flame, you might be curious, how do we apply this knowledge to real-life application?
Flame colors aren't just beautiful. They have practical uses in science, industry, and everyday life. Fireworks. This is one of the most spectacular uses of flame color science. Fireworks designer mix different metal salts into the explosive powder to create vibrant color in the sky. The chemistry must be precise so the colors stay bright even at high temperature. This is why fireworks are both an art and a science. Forensic science. Investigators use flame tests to identify unknown substances in crime lab. Even tiny traces of metal can be detected by their flame color. Cooking. Chefs check flame color to control heat on gas stove. A blue flame means efficient burning and high heat, while a yellow flame signals incomplete combustion and possible safety issue. Lastly, education and research. Flame tests may learning about atomic structure, fun and visual. They help students understand how electrons absorb and release energy. This application shows how understanding flame color combines beauty with science and technology.
Let's move on to the conclusion now. The color of a flame reflects both the chemical composition of the substance and the temperature of combustion. Different salts emit specific colors because their electrons absorb energy and release it as light. When returning to their ground states, hotter flames usually appear blue, while cooler flames produce yellow, orange, or red tones. These color changes are useful for identifying elements and have practical applications, chemical analysis, fireworks, and safety testing. I would like to express my sincere gratitude to my teacher and classmates for their guidance and support during this activity. Thank you for watching this video.